Hi, I'm Kathy Manley. This video covers Lesson 8, User Input Program Mini Project from Course F. The purpose of this video is to outline computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies to incorporate in the lesson, to model pedagogical strategies for implementing the lesson, and to review computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies addressed in the lesson. There are 3 lessons that we've asked you to do with your students this fall. Those include Lesson 3, Making Sprites, Lesson 5, a mini project with a virtual pet, and Lesson 8, a mini project with user input programs that we're covering today. Computational thinking concepts are the concepts programmers engage with as they program. In this lesson, students will focus on sequence and events as shown in bold. Powerful ideas are skills within a domain that change how we think or perceive the world and problem solve. The powerful ideas that operationalize computational thinking are also the computational practices that programmers develop when they engage with the computational concepts. In this lesson, we will focus on decomposition, algorithm, and debugging as shown in bold. Students will also use additional critical thinking skills, such as compare and contrast, cause and effect, predict, problem solve, plan, and observe. In this video, I will demonstrate this lesson and point out opportunities to use the following pedagogical strategies to support student learning. We will use student-centered learning, where students have time to play, think, and code, as well as direct instruction on key elements. We will also use the PRIM approach, where students predict, run, investigate, modify, and make a program. And lastly, we will focus on the process of problem solving. You may want to do Lesson 6 before you do Lesson 8. Lesson 6 is an unplugged activity where students create fill-in-the-blank stories similar to Mad Libs. This can help prepare them for creating stories for Lesson 8. You may also want to show them Lesson 7, Puzzles 1 and 2. The first puzzle is prediction. Show the puzzle to students to give them an idea of what they'll be doing in Lesson 8. Observe the code. What new blocks do they see? What do they think these blocks do? Maybe compare and contrast this code with what they did in Lessons 3 and 5. Then have them make their predictions and run the code. Discuss where they see sequencing being important. And it's a good place to talk about cause and effect and how the when name answered block might work. And then share the video from Puzzle 2 with the students. There's some vocabulary you may want to review from the video, such as input, prompt, and variable. The review slides in the slides that are provided in the lesson plan are very helpful for this discussion. And then discuss games and other programs that prompt students for information and then use that information later. Do they have programs that print their username when giving instructions? If you feel your students need more practice working with text, you can have them work through some more of the puzzles in Lesson 7 before beginning Lesson 8. Lesson 8 begins again with prediction. In this one, let's discuss decomposing and decompose the program to explain how event blocks work. Use the vocabulary. Where do you see a prompt? Where do you see the block for input? What variable or variables do you see? Have them make a prediction and run the program, keeping the PRIM approach in mind, where they predict, run, investigate, modify, and make. At the end, once they're done running, instead of having them click continue, have them click review code so that you can discuss debugging the program with a focus on cause and effect. What did the program print? What did you want it to print? Why did it not print pizza? And in this case, it's because the variables didn't match. And then stress the importance of selecting a variable that makes sense and using that variable consistently. Then we'll go on to Puzzle 2. In Puzzle 2, there are 3 puzzles, so it might be helpful to do a quick walkthrough of each puzzle to give students ideas for their own projects. Then give students time to select one of these programs to explore in detail. We want them to play, think, and code. They can make changes to see what happens, again, using that PRIM approach. Talk to students when they're done about their experience. What did they try? What did they like most in the program they selected? What ideas for their own projects were sparked while playing? You want to review some of the print and variable block shapes. And a nice way to do this is if you go back into the lesson plan on the right-hand side, you'll see teacher sandbox level. This allows you to pull up just a place to play around with the blocks. You can even have students tell you what they should do. It's good to talk to them about the fact that these are several puzzle pieces put together so that they can recognize that sometimes they're going to have to add a block before or after other blocks that they already have in place. Examine that variable and print boxes. The boxes can string together in a row, but only if the shape matches. So they have to make sure that this shape matches, unlike this one that's more of a square shape. And then we'll move on. And if they move on to puzzle 3, they're going to get this that says, are you sure you're ready to move on? The activity for this section right here is kind of an unplugged activity. And you'll find that also in the lesson plan. So if you look here in the lesson plan and pull up this mini project user input slides, that's these slides here. And what it does is it gives you an opportunity to take students through the 4 steps of program planning. So it's back to that problem solving idea. So they'll go through the first slide that talks about the type of project. And you'll notice that it gives you the choices here and talks a little bit about the types of bots they have in those projects. Then the students will plan their text in variables, plan what prompts they want to have used. And then it actually takes them on to sketching the scene. And if you look in that same piece with the lesson plans again, there is a printout for the students where they can actually go through and circle the type of project they want. It's a nice worksheet for them to be able to plan ahead and develop their program before they begin working on it. And so then they'll go into this lesson 4. And they will use they can do the greeting card, they can do the chat bot, they can do the blank space story, but they're going to do part 1, which provides feedback and guidance to them. When they click finish, it's kind of odd. They'll have to go back into puzzle 4 to click on the second part of their project. Part 2 is free play, where students can make changes or add to their programs. This level includes 4 hints of ways students can enhance their projects. So give them lots of time to think and to play and to code and to practice with these skills. And then we're going to wrap up by asking students what they learned. Remember, play is an important part of learning, so encourage them to share fun aspects as well as the computational thinking concepts and powerful ideas they remember, and review problem solving and encourage them to not jump into just dragging the blocks or just writing their program. So that worksheet will help really take them through that problem solving process. Talk about the role of observation, prediction, cause and effect. Review the compare and contrast, especially comparing what they've done in this lesson to what they did in lessons 3 and 5. Ask them what they did when something didn't work and discuss debugging again. And also in lesson 5, if you'll remember, we had a cross-curricular activity that combined science and ELA, which was providing energy for your virtual pet. That was where students created a scientific model showing a decomposer, producer, and consumer. The nice thing here is now they can add text to that. So if you have not done that project, you could begin it now, or if they've already done it, they can always go back and modify their project now that they can add text. Let's take a moment to debrief. We covered several computational thinking concepts and powerful ideas that align with this lesson. For sequencing, students needed to create receive an input before they could have the program create a response. Students created events to allow the user to interact with the program. When talking with students about the goals of the program and how to build the blocks, they were working with developing an algorithm by decomposing the code. And remember, algorithms are the steps students use to complete a task. When the program didn't run as expected, students worked to debug their programs. We also applied critical thinking skills by having students compare and contrast what they did in what they saw in this lesson compared to lessons 3 and 5. Explore cause and effect with user input, make predictions, solve problems, make a plan, and observe the code. We also employed a variety of pedagogical strategies by encouraging students to play, think, and code while providing direct instruction for key elements. Students also focused on understanding the problems, devising solutions, and using the PRIM approach to investigate and make their own programs. When you're working with students, it can be helpful to reinforce this vocabulary, especially in other classroom activities, to reinforce the skills that they're learning here. We encourage you to address additional computational thinking concepts and powerful ideas whenever the opportunity arises. I hope you enjoyed this activity with your students.